the characteristic of Gaussian distribution is shown by the central line called mean, which is the central tendency, the mean of measurements, and S is the standard deviation of measurements. How much is these values are getting deviated or dispersed from the central tendency is given by this measure called standard deviation. Okay, so what we as statistician usually do is m plus, so we define a boundary. So how this boundary, it's a closed boundary, m minus s and m plus s. So the x lies within these two boundaries. Okay, the x lies within these two boundaries. If this x lies within these two boundaries, then what I do, I take an integral using the integral calculus. The boundaries here reduces. Then area under the curve I calculate using the fundamental integral calculus. What I get is 0.68. So that is 68, shows that 68% of the measured data falls within this boundary. Okay, when I increase this data, when I disperse, so you put a standard deviation into 2, you disperse the data, then what happens? 95% of the data lies within the boundary. Then you increase it further, 99.7% of the data lies within this boundary. Okay, so this is one way of characterizing your captured data set. Okay, captured data set. And how do you characterize? Use the central tendency of the distribution, use the dispersion aspect of the distribution. What is central tendency here? Mean, dispersion aspect, deviation, standard deviation. Okay, statistical analysis of data comprises of two tests. One is multi-sample test, another is single sample test. So what is this multi-sample test? So this is a set of tests where repeated measurements of a given quantity are done for different test conditions. Okay, what are these test conditions? Test conditions here is keeping the thermocouple at the 30-degree path, at 40-degree path or 70-degree path, and using the same instrument or different instrument, or measuring, experiment is conducted with the same observer or different observers. So same observer is one set, different observers, okay, and different instruments and different conditions, they all become multi-sample. So I collect the data at different conditions to understand how this data is distributed, how this distribution distributed, so that I can avoid this random errors. Okay, that is the ultimate goal of doing this this procedure of experiments and multi-sample test. Okay, I don't have time. Let's say I don't have time. What I will do, I will go for a single sample test. So I use a single bath, I use a single instrument, I use a single observer to collect the data. That becomes the single sample test. Then comes another characterizing feature called histogram. So when the number of multi-samples are taken experimentally, there is a scatter of data. So you take 31 degrees, 31.1 degrees, there is a scatter of data points. Okay, and there is a central value. You take the mean of all these data points, you get a central value, and how much this central value are getting deviated, you calculate the standard deviation, you get your SD of the data set. Okay, another method, so these are characterizing the distribution. Another method, so when you do this, what happens is you get the same readings again and again, right? So they become the frequency. So when you have a frequency, that means like I have 31, 32, 33, 34, 31 reading, the 31 degree has come 4 times in my measurement, during my measurement of that device, during my testing of this device, or during the experiment. I got 4 times 31, I got 10 times 31, I got 15 times 31. Then what I do, okay, I do a plot called histogram. But in the present presentation, in this presentation, I'm giving some simpler example. Okay, let's see that there is this so now once again guys, these PPTs I have taken from internet for easy understanding, but most of the time one of the trademark and one of the most important stuff we engineers should always look in is to put the x-axis and y-axis labels clearly, so that the readers will be easily able to understand the characteristics of this plot. Okay, so for this discussion, what I will do, I will tell you what is this x-axis, what is this y-axis. X-axis is the marks taken by a group of people in a class. It ranges from 40 to 140. Okay, so this is 50, 60, 70, 80 intermediate values are the odd values, and these are number of people who have got that mark. For example, I say from 100 to 110 people, no, there are So what is the more frequently is nearly 25 people have got the mark between 100 to 120. Okay, so what does this? This is also a type of a bar chart, but the histogram groups them into ranges and tells you what is the frequency of these ranges or number of times these ranges have come. Okay, so that is the usage of histogram plots, arithmetic mean. So the best approximation can be made of a number of readings of the same quantities, the arithmetic mean. It is also called mean value. This mean is computed by summing all the values and dividing by the number of measurements. So total value is divided by the number. If there are 10 measurements, 10 temperature measurements, add those 10 temperature measurements divided by 10. Dispersion, the property which denotes the extent to which the value are dispersed or separated or kept away about the center value, that is the mean, is called dispersion. It is also known as the spread or the amount of spread or scatter of the distribution. So if you see this curve 1 has limits as x1 and x2, curve 2 has limits as x3 as x4. Based on your previous understanding of static characteristics, you can see that the curve 2 is dispersed more widely while the curve 1 is dispersed less widely. Curve 1 has the higher h value when compared to curve 2, and because of this dispersion the higher value, the mean value got reduced and mean value, so it's very clear, because of this distribution the mean value gets reduced. If the distribution is very small, if the dispersion, sorry, not the distribution, if the dispersion is large, mean value is small, and if the dispersion is small, mean value is large, and if the dispersion is small, what you can say, it has greater precision. The more the values are repeatedly coming again and again, but here it is dispersed between a wide range from x3 to x4. So all these things are interlinked, and as engineers we should connect all these things to understand fundamental properties of instruments and transducers. Okay, so these are some basic statistical terminologies that you should learn before even entering this statistical data analysis. So what are they? Range. So if you see those graphs, so what the range is? Range is the simplest and possible measure of dispersion, and it is the difference between the greatest and least value of the data. So example, the range of the curve 1 is x2 minus x1, and that of curve 2 is x4 minus x3. While the deviation is the departure of the observed reading from the arithmetic mean, so that is called deviation. And if you have so many different readings and you have so many different deviations, you calculate the mean of those deviations, they become average deviation. And if you have so many different deviations and you square it and you calculate the and you sum those deviations, they become standard deviation. Variance is the square of the standard deviation, is called variance. So that's it, folks. So these parameters are very well understood once we go into the problems. For static characteristics and for errors, we'll see few problems that will further give you better understanding of how these are even physically interpreted, physically calculated. Thank you for your time.